everyone, welcome back for another deep dive. We've been spending a lot of time talking about large language models and all the incredible things they can do.
Yeah, it's a really exciting field.
For sure. But this time, we're taking things up a notch.
Oh,
Yeah, we're going to go beyond just simple chatbot stuff. We're going to see how LLMs can actually use outside information.
like how to really think.
Exactly. It's like teaching a computer to not just talk, but to actually learn from the world around it. So we're diving into this research paper titled Retrieval-Augmented Generation, or G and Beyond.
Oh, wow. I've heard of that one.
You familiar with it?
I've skimmed it. Looks dense.
Oh, yeah. It's pretty intense. But that's why we're here, to break it down.
Make it digestible.
Right, because this stuff has huge implications. Imagine LLMs that can analyze financial data or help doctors diagnose illnesses, or even,
Assist lawyers.
yeah, all while staying up to date with the latest info. This isn't just about having a super smart chatbot. It's about creating powerful tools.
For all sorts of fields.
Exactly. But before we get too carried away, let's break down what this retrieval-augmented generation actually means.
Okay, so think about it this way. Traditional LLMs, they're trained on massive amounts of data.
Right. Huge data sets.
Yeah, which is great for general knowledge. But that information, it can get outdated pretty quickly. And sometimes, get this, LLMs can even hallucinate, like make up information.
Hallucinate.
Yeah.
Yeah.
They just start spitting out stuff that sounds plausible, but is totally made up.
Whoa. That's a little unsettling.
Definitely. Can you imagine relying on an LLM for medical advice and it starts inventing symptoms?
That's a scary thought.
Yeah. That's where RAG comes in. It basically gives LLMs access to external, up-to-date information. It's like giving them a direct line
A
to...
world's knowledge.
Precisely.
So our RAG is like a super-powered research assistant for the LLM, making sure it's working with the most current information. I like it. But the paper doesn't stop there, does it? It actually categorizes the ways LLMs use this external data.
Oh, it gets way more granular.
Yeah. Into these 4 levels of queries.
4 levels. And understanding those levels is key to understanding how complex this stuff really is.
Right. Because it's not just about finding information, it's about...
Knowing how to use it.
Exactly. Okay, so level 1. Explicit fact queries. This sounds like the simplest type.
It is. It's the most straightforward. Think of it like asking, where were the 2024 Summer Olympics held? The LLM can just pull that answer straight from a database.
Like a supercharged Google search.
Basically.
Got it. Simple and efficient. Okay, now level 2 is the implicit fact queries. These seem a bit trickier.
A little bit, yeah. Here, the LLM needs to put together different pieces of information to get to the answer.
Okay.
For example, let's say you ask, what is the majority party in the country where Canberra is located?
Okay.
Well, the LLM needs to know that Canberra is in Australia and then figure out what the political landscape is in Australia. It's like...
2-part puzzle.
Yeah, exactly.
Okay, so we're building on the complexity here with each level. So level 3, interpretable rationale queries. This is where things start to get really interesting, right?
Absolutely. Now we're talking about not just facts, but also understanding the why behind those facts.
The reasoning.
Exactly. Applying rules and logic to solve real-world problems.
Okay, so give me an example. Like, paint me a picture.
Sure. Imagine you're asking a medical LLM. You say, how should I diagnose and treat chest pain?
All right.
The LLM, it can't just regurgitate symptoms. It needs to understand medical guidelines, best practices. It's got to think.
Like a doctor.
Yeah. More than just a medical encyclopedia.
Wow. Okay, so that's pretty impressive. And then we have level 4, hidden rationale queries. This sounds like the ultimate challenge.
It is. This is where it gets really complex.
It's really complex.
Now we're talking about cases where the reasoning behind a decision is not explicitly stated anywhere.
It's hidden.
Yeah. The LLM has to infer the reasoning from the data itself, like a detective.
Piecing together clues.
Exactly.
Yeah.
So, for example, let's say you asked an LLM to analyze a bunch of financial reports and predict a company's future.
Mm-hmm.
It would need to sift through tons of data, look for patterns without any clear instructions on what to look for.
And make a judgment call.
Yes. And the rationale for that prediction, it might not be written down anywhere. It has to learn to connect the dots. Exactly.
Yeah.
Like a human expert.
This is mind-blowing stuff, but it's also a little daunting. I mean, even with RAG bringing in all this external data, how do you teach an LLM to actually process and understand it all?
Yeah.
Especially when you think about all the different formats information comes in.
Yeah, that's a huge challenge. And that's what we're going to dive into next. There are some really clever solutions being developed to tackle that problem.
Okay, so my brain is officially buzzing. We've got these 4 levels of queries, but how do you actually teach an LLM to deal with all this external data?
Right, because it's one thing to give an LLM access to information.
It's another to make sure it can actually use it.
Exactly. It's like giving someone all the ingredients for a fancy meal, but no recipe.
Or cooking skills.
Right. You need to teach the LLM how to actually work with what it's given.
So what are some of the biggest challenges researchers are facing with this?
Well, one of the biggest hurdles is just the variety of data formats out there.
Oh yeah, it's not all neat and tidy.
No.
Mm.
No, it's not all nicely organized text in a database. We're talking about research papers, news articles, social media posts.
A whole jumbled mess of info.
Yeah, and a lot of it isn't even text.
Right. There are images and charts and...
Graphs, videos. How do you teach an LLM to understand a pie chart?
Or a photograph.
Exactly. That's the challenge of multimodal data. It's like
Yeah.
trying to teach someone to read in multiple languages at the same time.
Wow, yeah, that's a good analogy.
One approach is to try to convert everything into text.
Like, translate it?
Yeah, kind of.
Yeah.
So imagine turning a chart into a series of sentences.
Describing what it shows.
Right. But then you have things that are just too complex to easily summarize, like a scientific diagram.
Or a video clip.
Yeah. So for those cases, researchers are using something called multimodal embeddings.
Embeddings.
Yeah, think of it like creating a universal language that the LLM can understand.
Like Esperanto for data.
Exactly.
Yeah.
It lets the LLM process and compare different types of information, even if they weren't originally in the same format.
So you're either translating it or finding a way to represent it in a way that the LLM already understands. Clever. But even once you've dealt with the formatting issue, there's still the problem of actually finding the right information, right? It's like looking for a needle in a haystack.
A very big haystack.
Yeah. So how do you make sure the LLM doesn't get lost in all that data?
Well, one approach is to use dense retrieval.
Dense retrieval.
And uses machine learning to understand the meaning behind your query.
Not just the keywords.
Right. So instead of just looking for a document that contains the exact phrase Summer Olympics 2024, it might understand that you're actually interested in
The location.
the medal winners.
The controversies.
Yeah. It allows LLMs to understand the nuance. Exactly.
Yeah.
Which is especially important when we start talking about those higher level queries.
Where the LLM actually needs to reason.
Yes. It needs to connect the dots.
Right. Like it's the difference between knowing a bunch of facts and actually being able to use those facts
To solve more back.
to make an argument, to think critically.
Exactly. And to handle those more complex queries, researchers are developing these special techniques to guide the LLM's reasoning process.
Okay, now I'm really intrigued. What kind of techniques are we talking about?
Well, one approach is called prompt engineering.
Prompt engineering.
It's all about asking the right questions.
Okay.
Instead of just asking the LLM for an answer, you carefully craft a set of instructions or a series of questions that give it context.
Like a roadmap.
Yes, a roadmap. Instead of just asking a medical LLM, what's the diagnosis?
You might give it some background information about the patient,
Their symptoms.
medical history.
And maybe even point it to relevant sections in a textbook.
So you're basically giving it a crash course.
Exactly. And by structuring the input in this way, you can help the LLM focus on the right information.
And use its reasoning powers more effectively.
Right. Another cool technique is called chain of thought prompting, or COAT.
Chain of thought.
It's a way to encourage the LLM to think step by step.
Oh, so you can see how it's getting to the answer.
Exactly. It makes the reasoning process more transparent.
Which I like. It's always a little unnerving when you don't know.
How the machine is thinking.
Yeah, exactly. Blackbox AI is kind of creepy. So with co-prompting, it's like you're asking the LLM to
show its work.
like a student solving a math problem.
Yes. Instead of just giving you the final answer, it explains how it got there.
So for our chest pain example, the LLM might say something like, the patient is experiencing chest pain, shortness of breath, and nausea. These symptoms, combined with their age and medical history, suggest a possible heart attack. We should consult the section on myocardial infarction in the cardiology textbook.
Exactly. And by having it articulate its thought process like that, we can gain insights into...
Where its logic is sound.
Yes. And we can also use that to refine our prompts and improve the LLM's performance over time.
It's like having the LLM teach us how to teach it better.
Exactly.
But I imagine crafting these prompts and chains of thought, it can be pretty time-consuming.
It can be. But the good news is that researchers are developing tools to help automate this process.
Oh, like using machine learning to optimize the prompt?
Yes. Or even generate COT prompts automatically.
So it's like having a personal assistant.
For your AI assistant.
Ow, that's efficiency. But even with all these tools, how do you teach an LLM to handle those really complex hidden rationale queries where the why isn't clearly stated anywhere? That seems like a whole other level.
You're right, those are the toughest ones.
Yeah.
And they require a whole different set of approaches. It's almost like teaching an LLM to develop intuition,
To pick up on patterns.
to make judgments based on incomplete information, like we humans do all the time.
All right, so we've covered a ton of ground. Different levels of queries, the challenges of processing all this external data, and even some pretty cool techniques for guiding an LLM's reasoning.
There's a lot to take in.
It is. But now let's get to the heart of it. How is all this external data actually integrated into an LLM? How do you make it all work together?
Well, the paper outlines 3 main methods: context, small model, and fine-tuning.
3 methods. Okay.
Each one has its own strengths and weaknesses.
So it's like choosing the right tool for the job.
Exactly. So let's start with the simplest one, context.
Context. Okay.
The basic idea here is that you're giving the LLM a cheat sheet.
A cheat sheet, yeah.
You identify the key data snippets from those external sources, and those snippets become part of the input to the LLM.
Along with the query.
Right. So it's like saying, hey, LLM, here's everything you need to know to solve this problem. Go nuts.
Straightforward enough. What are the downsides?
Well, the main limitation is that LLMs have a finite context window. There's a limit to how much information they can process at once.
Like trying to cram too much stuff into a suitcase.
Exactly. So this approach, it works great when you can narrow down the knowledge to a manageable chunk.
But not so much for really complex queries that need tons of background.
Right. For those situations, you might want to go with the small model method.
Small model. So we're training a mini-me version of the main LLM.
Kind of. You train a smaller model, but it's specialized.
Okay.
And this small model, it becomes like a subject matter expert.
Ah, I see.
And it can then guide the larger LLM.
So it's like a team of specialists working together.
Yeah, each with their own area of expertise. And this way, you can handle much larger data sets and more complex reasoning.
Because you're dividing and conquering the information overload.
Exactly.
But I'm guessing even training a small model still takes a lot of
Time and resources.
Yeah.
Definitely. It's a trade-off.
Right. Okay. And then we have the fine-tuning method.
This is the most intensive one.
So this is where we're really getting into the nitty-gritty.
Yes. With fine-tuning, you're actually further training the LLM itself on the specific external data you want it to work with.
So we're not using a separate model anymore.
Right. It's like taking a general doctor and sending them to become a specialist.
So you're upgrading the main LLM with specialized knowledge.
Precisely. And this can lead to the highest performance because the LLM becomes deeply integrated with that data.
But couldn't that introduce bias if you're only training it on a specific data set?
That's a really good point. Fine-tuning requires a lot of care. You have to make sure the training data is balanced, representative.
And that you're not making the LLM too specialized?
Yes. You don't want it to only be good at one specific thing.
Right. Like if all you have is a hammer, everything looks like a nail.
So it sounds like choosing the right integration method is a delicate balancing act.
It is. You have to think about the complexity of the task, the resources you have available, the level of performance you need.
And the risks involved.
Exactly. It's amazing to see how much progress has been made in this field, but it also makes you realize the ethical considerations that come along with it.
Oh, absolutely. As these LLMs become more powerful, as we integrate them more with the real world, we have to be really thoughtful about the implications.
Make sure we're using this technology for good.
Exactly.
Well, this has been another incredible deep dive. We've gone from understanding how LLMs can use external data to think to exploring the nuts and bolts of how that integration actually works.
And we've only just scratched the surface.
I know. It's mind-boggling to think about what the future holds for this technology. Thanks for joining us, everyone. We'll be back next week with another deep dive into the world of AI. Until then, keep learning and keep exploring.